This UAS tutorial video is brought to you by AmericaView, a nationwide consortium for remote sensing education, research, and geospatial applications. This project was supported by a United States Geological Survey grant, and its contents are solely the responsibility of the authors and do not necessarily represent the official views of the USGS. Mention of trade names or commercial products does not constitute their endorsement by the U.S. government. Hello everyone, welcome to part 3 of our 5-part video series on using small unmanned aircraft systems to assess rainwater harvesting potential for urban multifamily housing. This part of our video series is titled Image Collection with UAS, and in it we will discuss some of the various procedures that are necessary when collecting aerial images with your UAS. In order for your image collection process to be fruitful and your map products to be accurate, we need to make sure that we have a firm understanding of how to create an efficient flight plan that will satisfy our research needs. For this video, I will discuss 3 main topics. The first topic I will go over is the process of flight plan creation. Then I will discuss several of the optimal conditions and settings that you need to be aware of when creating your flight plan. And lastly, I will go through the process of actually conducting your flight mission with your UAS. When creating your flight plan for your site of interest, you need to first determine your flight goals. And this can be accomplished by asking yourself a few simple questions. Will your flight be conducted in a dense urban area, or will it be conducted in a spacious rural area? Are you primarily interested in 2D maps, or do you require elevation data and need a 3D map? What's the scale of your project going to be? Are you mapping a small neighborhood, or are you mapping a large swath of farmland? These are all questions that you need to ask yourself before doing anything else in the flight plan creation phase. In our example, we will be conducting a flight in an urban multifamily housing area. We are interested in a 2D map since we want 2D aerial measurements for rainwater harvesting, and our project would be considered small scale. Now that we understand our flight goals, we then need to look at the variety of flight planning apps that are widely available for use with your UAS. Since most research-worthy UASs are controlled by a smart device connected to your remote controller, these apps can provide lots of flexibility in your flight plan designs, with each particular app having its own pros and cons. Once again, the app that you'll end up using will more than likely depend on whether you need 2D or 3D products. It will also depend on your particular smart device that you plan to use, if it is an iOS device or an Android device. For our example, we elected to use Pix 4D Capture to create our flight plan, and we'll be using it on an Apple iPad tablet. Once you have selected your preferred flight planning app, you now need to choose the optimal settings for your flight. Generally, these settings will include altitude, speed, image overlap, camera settings, and battery management. The altitude setting is extremely important because it can significantly affect the resolution of your final map, as well as the time it takes to collect all of the images. If you fly your UAS at a lower altitude, then the resolution will be much greater. However, the flight will take much longer to capture the same amount of area. For altitude, generally the remote pilot needs to find a balance between desired resolution and desired flight time by selecting the altitude. The speed setting is another setting that the pilot should be aware of. For most flight planning apps, the app itself will actually determine a flight speed for the UAS based on your other chosen settings. Therefore, the pilot normally does not need to worry about determining an optimal speed since most apps will do it for you automatically. The effect of the UAS's speed can be seen in the quality of the individual images captured since oftentimes if the UAS is flying too fast, then the images will be blurry and not very crisp. Image overlap is another setting that is arguably just as important as the altitude setting. Since we are interested in combining multiple aerial images into a single composite map, then a certain amount of overlap between the images is needed. In order for the processing software to fully understand how the images should connect, there often needs to be a high amount of overlap. Typically, with image overlap, more is better. However, more overlap results in longer flight times. So once again, there's a balancing act like there is with altitude. Camera settings are another thing that you should consider. You by no means need to be a photography expert to accomplish your mapping objectives, but understanding some of the basic camera settings of your specific UAS can help you out greatly. Typically, the optimal camera settings will vary between project and camera model, so there's no single best set of settings to use. The last thing you should consider is your battery management. This is not a setting per se, however, it is a factor that needs to be considered because it can create limitations for your other settings. Oftentimes, if you're striving for optimal map quality, then your flight times will need to be longer. Therefore, you'll need to make sure you have enough battery power to complete the entire flight. If you only have so many batteries, then you can create your flight plan settings based around your time limitations in the air. For our example, since we are using a DJI Phantom 4 Pro quadcopter, we elected to use an altitude of 45 meters above the ground, or approximately 147.6 feet above the ground. Our speed setting was 3 meters per second, or approximately 6.7 miles per hour. We utilized a frontal overlap of 85% and a side overlap of 80%, and we utilized the default camera settings for sunny conditions. So now that we fully understand all of the various settings and what they do, we now need to actually create the flight plan. Within your flight planning app, after selecting your settings that we discussed in the last slide, you will then need to delineate the actual area you plan to fly over. Just like in a GIS software, you'll simply drag and drop a polygon shape over your area of interest and adjust the boundaries to reflect your focal area. The flight planning app should automatically adjust the grid pattern or orbital pattern to fit within your polygon's boundaries. And generally, when creating these boundaries, it is recommended to extend the polygon's boundaries past your actual area of interest, so that there are plenty of overlapping images along the edges of your map. In addition to the pattern you select to use, you will also need to determine if you want the camera angled at an oblique angle, or if you want it looking straight down in a nadir view. Normally, nadir views are used for 2D outputs, and oblique angles are used for 3D outputs. For our example, we will use a grid pattern and a nadir view with the camera since we are interested in the 2D map output. Once your flight plan is finalized, then you can organize your documentation, permissions, and pilot's log in preparation for the flight to be conducted. Whenever conducting a research or commercial UAS flight, then it is expected for you to have your license and other related documents with you on hand. If your flight required extra permissions or approvals, then make sure to have documentation of that with you as well. Lastly, before conducting the flight, you want to make sure your flight plan is compatible with your model UAS. On the day of your flight mission, before sending the UAS into the air, you need to first make sure to fully assess the conditions of your site of interest. You need to ask yourself several things like, how's the weather? Are there any obstacles that I need to be aware of? Do I have the ability to meet the expectations of all required laws and regulations? If I have flight observers assisting me, are they ready and knowledgeable of the plan? And lastly, am I prepared for unexpected emergencies, like a loss of signal from the UAS? Once you have fully assessed your surroundings and everything looks like it's good to go, then you can prepare to conduct the flight mission. In order to conduct the mission, you first need to upload the flight plan to the UAS and make sure all requirements are met. Once the flight app designates that everything is okay, then you can press start and let the UAS begin its automated flight. While the UAS is flying its pattern over your site, make sure you maintain visual line of sight with it at all times so that you're following the FAA's regulations. Once your UAS is finished with the flight, it should automatically land itself, or it might require the pilot to take over and land it. After it lands, then you're able to begin downloading your imagery and organizing it for later processing. For our urban multifamily housing site example, the garden apartments, we obtained 754 aerial images in about 45 minutes of flight time. Now that we have finished our flight and acquired our imagery, then we are ready for our next step in the process of creating the maps and can move into part 4 of the video series. Part 4 of the series is titled Image Processing, and it will cover the necessary steps for turning your collection of images into a single output map. The first topic we will cover are the guiding concepts behind the image processing. Then we will detail the steps needed during the processing. Lastly, we will go over the outputs and how we can interpret them. Thank you for watching.